Welcome back to the lecture series where we are discussing the big data analytics in the industrial IoT system. I have discussed various elements, the structure and the layer of the industrial IoT system, the use of big data analytics. So, what are the various elements, or the if a big data analytics in IIoT is a big system, what are the subsystems, what are the subsystems, what elements could be used? There could be specific sensors, there could be specific softwares. So, let us take a few examples or case studies. The first case study I would like to take is the gas pipeline case study. How does the big data analytics or installing the sensors at different points in the gas pipeline to avoid leakage, for regular maintenance, for having the data from the remote areas. This will help us to have the financial as well as the long life benefits. So, oil and gas markets are considering what can be acquired from deploying IIoT modern technologies by gathering and analyzing the data from the history assets while realizing significant gains from connecting the newer equipments. So, this is a case that is studied by McKinsey, and few things are also reported by Bain and company. This is similar to what we can do. Suppose we have own gas agencies like Oil and Natural Gas Corporation India, ONGC. So, major concerns of a gas pipeline is, number one, to guard the pipelines against device failures. Or preventing extensive downtime, and also assist in predicting when the gas extraction or oil extraction equipment could fail. So, along with searching new oil reserves or gas reserves, it was one an important point to maintain the value of the current properties which suppose ONGC is holding. So, this required transparency in the business practices and tighter regulations were there. So, they are maintain the existing resources, then bringing transparency. Transparency means whatever data is submitted or whatever data is analyzed is also to be kept transparent, because in case of any catastrophe or any failure, the stringent requirements, the government regulations are there which are to be reported back. So, everything has to be reported timely and in a transparent manner. So, this has to be met to deal with the tight regulations. This is one major issue. With the industrial IoT case study, one of the cases it was taken was for the oil reserves which were distant, because oil reserves are generally distant and the places where you manage them are at offices or the cities which are big or so. So, the distant oil reserves, there are different kind of challenges for them. I would say challenges for distant oil reserves. These were, I would put A, these required ongoing cost optimization. ongoing cost optimization, because the oil reserves were distant apart, number one. Number two, they were not very productive. The volume of the oil that was being extracted or produced or generated by them was quite low, and the investment which was required in purchasing these sensing equipment or the sensors, that was heavy. So ongoing cost optimization, there is a trade off between the investment and what would be actually get out from finally applying or employing the analytical models and getting the reduction in the cost in the total maintenance. So this was a cost optimization problem statement. These statements akin to the hypothesis that we can design. So this is cost optimization while installing the sensing units or so. Second was the connectivity. Connectivity in the remote areas, which means it was difficult to have access to power or web connectivity both. So both electricity and internet. On the top of having the sensing units itself being very expensive, the installation of these units on the equipment which were old which were literally getting outdated or so, to put those sensors over there, installation cost was also very heavy. So this was also a challenge, I would say. Pricey hardware installation. It means the cost of sensing units is high, cost of installation is also high, which increase the cost of the original sensor. So additionally, the software applications also need to be built. So return on investment was very crucial here. ROI was under a question, because smaller procedure as well as more remote and end of life wells to justify the IIoT applications, this is a challenge. Now operators were to be able to manage, analyze and take actions on vast information collections from numerous physical assets which were deployed for production and transformation of hydrocarbons. So it is a big benefit of IIoT that it enabled the consolidation of disparate data into structured data groups, and which can be analyzed into the small clusters and to find patterns which indicated a potential risk or equipment failure. This could be done. So IIoT allows robust proactive measures. Like preventive maintenance or activation of extremely early caution signals or so. Then it could also help to preserve the crucial uptime. Which in turn would definitely enhance the financial performance. So individuals should have been able to process data. So the elements here would be individuals, the processes, the data points from the processes, the points across upstream, flow, midstream and downstream. So there are countless ways that a business IoT can be used in an oil and gas industry, moving varying quantities and quality of goods from various locations to new end user as well as markets is a difficult task for the midstream market. Industrial IoT is an essential tool for the midstream service because it connects pipe networks, sensors. So, in the midstream, it can connect pipe networks, sensors, leak detection, alarm systems, or emergency situations. So, this is the major business obstacle and the problem statement that is there. So, business obstacle, if I put it in a very clear terms for this case study, could be the pipes are generally susceptible to multiple structural failures, which means deboning, cracks, leaks or rust could be there. Stress on the pipeline varies frequently. So, if I try to put it in a block diagram, I could see we have hardware, we have software, we have communication between them, and we have cloud and the IIoT platform. In the hardware, definitely pipelines constitutes the first element. Then we have the sensors. What different sensors are there, that also we will discuss. Then we have the radio frequency components, which are a kind of sensors itself, and we have a process control system. The software, definitely data collection, device integration or real time analysis is required. So, hardware goes to the software system in which data collection is the major concern. I will put communication where Wi-Fi, that is wireless LAN, or some connections too, if not Wi-Fi, maybe if not 5G, 4G connections or volt connections, LTE connections were required to transfer the data. So, this has to have a gateway that how the data is transferred. It could be IP4 or IP6 kinds of the data. So, data storage is taken care by cloud. It could be again supervised controlled data, and the IIoT platform, which is a user interface or web app or my mobile app. That is, the operator or the person who is going to monitor should have it on its computer on a website or on a mobile. So, this is majorly a structure of the elements of the case study that we are going to take. Now, what could be have been the challenges in the pipes where multiple structural failures could come? The pipes could have cracks, leaks, rust or so. The stress on the pipelines varies frequently. As I said, the majority of pressure drops are caused by regular activities like chemical plant expansion or nuclear power plant gas down or so. So, other stress reductions might be brought by odd circumstances like leaks or ruptures. So, developing an automated system which is both quickly and accurately respond and detect the anomalies is required. So, the main causes of tension in the pipes could be, if I put them, I can just also deploy what kind of sensors would help us to take care of them. So, it could be temperature in a pipeline, it could be gas flow and oil flow, or detecting leaks, or the structure of the pipeline in itself deformed. So, here the leaks or the major tension in the pipe that has come could be because of the internal stresses, dead weight, maybe restrained thermal expansion. Incomplete relaxation is important to consider in light of increased temperature and stress levels, as well as other potential negative influences like increased friction in pipe supports that could also add to the issue. An essential prerequisite for maintaining functional dependability on creating a maintenance along the evaluation periods and ensuring risk free long term operation of the gas plants is online surveillance of the levels of exhaustion. These pipes are thick walled components, and relaxing the pipe system above the specific capability is not allowed. So, there were requirement of the sensors for different applications. For example, for temperature a thermocouple could come, for gas flow there could be flow sensors for the leakage in the oil or so, there could be piezoelectric sensors to understand whether the structure in the pipeline is deformed or not. So, these sensors are required. The industrial wireless technologies majorly fall into two broad categories that can have significant impact on oil and gas operations. One is for the field networks, one is for the plant networks. Both of them can be wireless technologies depending upon the requirement. For the plant itself, Wi-Fi could be employed. For the field, a moving technology is required. So, I would just put them into two forms: field and plant. So, for the field networks or for the field network sensors, the gadget applications are required. For the plant networks, business and procedure needs were required. So, this could be infrared radio frequency, which makes the part of the hardware itself, or I will put them here as well. It could be infrared sensor, it could be RF, that is already mentioned here, it could be RFID as well, it is radio frequency identification or so. And maybe at satellite itself the things could be stored. Now, to deal with these challenges which are put here, temperature in a pipeline, gas flow and oil flow, detecting leaks, structure of the pipeline is deformed or not, there has to be sensors such as acoustic sensing devices. Acoustic sensing devices which are used to identify acoustic signature variations that have been violated. That means the gas flow is not streamlined. So, this could be one. Other than that, we have flow sensors. Flow sensor is a device that is used to calculate the liquid's velocity. It is for oil flow only in general. Then we have fiber optic sensors. It is used majorly for structure of the pipeline. If it is deformed, that could be seen if distortions are there. Then we have piezoelectric sensors. which helps us to determine whether the pressure flow or pressure changes are there, and that could be also measured. Temperature is also to be measured. We need to have a thermocouple, right, or maybe a thermal level detector, which I have put as IR. Temperature level detector. This is used to gauge how a metal's electric wire resistance varies with temperature. So, that is helpful to have surveillance and have to have control options, which will be provided by the wireless M2M communication. Wireless M2M communication, if I say M2M, means the communications happen between machine to machine. Along with the challenges or the problems which were mentioned here to guard pipelines against device failures, to prevent extensive downtime, or assist in the predicting whether the equipment would fail or it could fail or so, there are other challenges. Human safety, that I will put here. Human safety was also a challenge. So, the oil and gas companies are using big data and predictive analytics to identify new oil and gas sources without having to conduct potentially hazardous operations. That means difficult to reach areas or where there could be potential hazard to the human, those could also be reached using IIoT sensors only. This is human safety, that is also enabled. Next point is reducing the production costs. But big data can be harnessed by these companies to improve the production efficiency, that is reducing cost. So, data analysis is being used to identify the right place of digging the oil wells even. Then upstream, midstream, downstream optimization could happen, that I just said. So, this remains one of the most important applications of big data analytics in the oil and gas industry. Drilling efficiency is improved by implementing best practices which were formulated by harnessing the data from the past, that is the automated monitoring service device, or automating monitoring devices or services are developed. Then predictive and preventive maintenance is always there. Then improving offshore operations. Improving offshore operation means whatever is away from the plant. So, according to a report by McKinsey that as I said, a typical offshore platform runs 75% of its maximum production capacity. On an average, this shortfall represents hundreds of billions of an annual revenue. A primary reason for this performance gap is the operational complexities in the production and processing facilities. So, a control room operations of an offshore platform must be analyzed, and when we analyze that, the data is really huge or humongous, that is big data is generated, and there could be a sensors maybe amounting to tens of thousands, which could be considered as an external factor. But these are very well required or very useful if a typical offshore platform is to be identified using the big data analytics. So, an advanced analytics can be used to identify bottlenecks and suggest prescriptive actions essential for smooth operations and conditions. So, these sensors are installed: acoustic sensors, flow sensors, fiber optic sensors, piezoelectric sensors, thermocouple. They have only mentioned a few important and critical sensors. There are, as I said, thousands of sensors which are installed. So, these sensors collect the information and various data points are collected, and which is cleaned, moved to the next level. Finally, the GUI, the web browser or the application, mobile application is there, that helps us to understand or take decision. So, this acts as a decision support system to understand the operations of the oil and gas companies, digging oils, then maintaining the oil pipelines or so. This all is assessed upon. So, majorly if I say outcomes of this is number 1, condition based maintenance alerts. Which means industrial IoT actively monitors the pipelines and alert, and designated supervisors, mining engineers or environmental engineers or operators, they can take the call using this decision support system. The decision could be taken by this support system when the parameters in the pipeline depart from their recommended specifications. So, this can prevent downtime because information has been gotten by the people who are not going to take the decisions, and also it extends the life of the pipeline, because the decision could be taken then and there. The decision taken time is also almost real time. So, the defect does not remain for the more time, and or the defects does not aggravate. So, that is why the life of the pipeline is also enhanced. Second major outcome I would like to put here is that it also fulfills the corporate responsibility or corporate social responsibility. What does it do? Is it not 2% CSR fund? CSR does not only involve the financing or so. CSR funds are taken by the people or the startups to develop the products that will benefit to the society in general. Here, when I say CSR, it means minimizing their emission of hydrocarbons. The pollution is reduced, the leakage is reduced. If the leakage happens, if something very undesirable happens in the case of accidents, that is a big backlash to the company. So, the corporate social responsibility is enhanced while reducing the environmental impact. Ecological impact. The development of the industrial IoT system has given rise to the ability to increase productivity. We will put it as third point. Or control and process monitoring helps us to have a better process. So, by extending current capabilities like real time data capturing, machine breakdown signals, real time control, data logging, information evaluation, visualization, industrial IoT benefits the manufacturing businesses without being constrained by either technical or economic dimensions. Smart machines are used in factories as part of industrial automation to carry out manufacturing processes autonomously with little assistance from operators. The ability of the computers and software to automate, improve, incorporate the various components of the production system has become more important with development of microcontrollers and software. So, with the relation between things, environment and people, if I say internet of things, so it is internet, things, people, environment, everything is connected. So, this is one of the case studies. I will now come to the next case study on the Rolls-Royce engine that we will be taking in the next lecture. Thank you.